confined space entry. Equipment. Confined spaces pose a high risk of injury and death. Hazards in confined spaces can result in fire, explosion, unconsciousness, asphyxiation, engulfment, toxic exposure, or drowning. Confined space incidents can happen suddenly, often without any warning that something is wrong. Employers must take the necessary steps to ensure worker safety around confined space entry. Welcome to the Energy Safety Canada video series on confined space. This video focuses on common equipment used for confined space entry. The tasks that workers might perform during confined space entry are too numerous to cover in detail, but there is equipment that is common to confined space entry. Two groups of respirators are used for confined space entry: air purifying and air supplying. In the air supplying group, there are two types: supplied air breathing apparatus, SCBA, and self-contained breathing apparatus, SCBA. In the air purifying group, there are also two types: non-powered and powered. They can each be gas and vapor removing, particulate removing, and combinations of those. We will briefly look at the additional PPE used for confined space entry, as well as the air supply and additional equipment. Supplied air breathing apparatus, SCBA. These units provide workers with a continuous positive supply of air from an air trailer and have a small emergency escape bottle. The advantages of SCBA are that it can give a constant supply of air for long periods. It is relatively lightweight and small, which makes it easier to access tight spaces. The disadvantages are that the air lines can be tangled, pinched, blocked, or damaged, and the supply may run out or be disrupted at the source. Airlines have a limited length. There is also no alarm on the emergency escape bottle. Self-contained breathing apparatus, SCBA. These units typically use a 30-minute rated bottle, which the worker carries, along with a positive pressure air regulator system. The advantages of an SCBA is that it is easier to maneuver, there is no airline to be tangled, and there is no need to rely on an external source. The disadvantages include a limited air supply, typically only 15 to 20 minutes on a 30-minute rated bottle. The pack is heavy and awkward, and can be challenging to maneuver in tight spaces. The capacity of the SCBA tank is rated in minutes of use. However, the amount of time a worker can get from the tank depends significantly on the physical demands of the individual. Breathing efficiently, individual capacity, and worker activity level are variables that impact how quickly the tank will deplete. Air purifying respirators. An air purifying respirator passes ambient air through a filter, cartridge, or canister, which removes particles, vapor, gas, or any combination of these contaminants. Interchangeable cartridges, filters, and canisters come in a number of types and classifications, so that an air purifying respirator can be very flexible and can be used under various conditions. With non-powered air purifying respirators, the wearer must draw breath through the cartridge and create a negative pressure in the mask. The resistance of the filters can be considerable and make breathing difficult. Powered respirators are an innovation that overcomes this issue, but is limited to battery life. The air purifying respirator has the following advantages. It is lightweight, has no airlines, and no chance of entanglement. It provides the highest degree of mobility for a worker. Its disadvantages are that it can only operate in some environments. Cartridges have a limited capacity and may deteriorate based on temperature, humidity, and the working environment. An air purifying respirator cannot be worn in an environment with less than 19.5% oxygen, or in any environment considered immediately dangerous to life or health. Immediately dangerous to life or health refers to any environment which impairs the worker's ability to leave the area, or which can lead to irreversible health effects, serious injury, or death within 30 minutes. A list of IDLH concentrations can be found in the NIOSH Pocket Guide to Chemical Hazards from the U.S. National Institute for Occupational Safety and Health. Be sure to know the contents of the atmosphere of the environment and the capabilities of the cartridge. Always refer to the instructions and maintenance manuals for limits of the cartridge and instructions on how to maintain and use the respirator. Respirator Fit. A common feature of all the systems mentioned is the masks used. In the case of the SABA, SCBA, and powered air purifying respirators, these systems all create positive air pressure on the inside of the mask, meaning the air will push outward to keep the ambient air from entering. These masks all have a minimum pressure and volume requirement to function correctly. In all cases, the respirator must fit properly and form a good seal for the wearer. A fit test is done to ensure the mask will not allow outside air to leak into the respirator and harm the wearer. To ensure a good fit, nothing, including glasses, headwear, or hair, should come between the skin and the seal. Fit testing requirements vary by jurisdiction. Employers must conduct fit testing to meet the legislative requirements and industry-accepted best practices. Inspections of equipment. It is essential to inspect all equipment before and after each use. Your life may depend on it. Follow the manufacturer-specific inspection criteria and your company-specific procedures for documenting and reporting inspections. Check for cracks, leaks, twisted lines, and harnesses. Ensure the buckles function well, valves function and are not dirty. Confirm threads are clean and not cracked. Air bottles should be dent-free. Airlines need to be cleaned and checked for cracking, wear, and damage. Before storing equipment, it should be cleaned and dry. Mold can be a significant hazard, not only for workers, but for anyone checking and servicing the equipment. Additional PPE. In addition to the respiratory equipment, additional PPE used can include hard hat, FR coveralls, disposable coveralls, self-retracting lifeline, barrier cream, chemical suit, chemical gloves, hearing protection, fall protection harness. Refer to your company-specific procedures and the task hazard assessment for the PPE specific to the work you are about to undertake. Air supplies, air trailers. Air trailers for confined space entry typically will have large capacity banks of air cylinders arranged in multiple delivery banks. Typically, each bank will have a regulator and alarm for monitoring by external personnel. Distribution manifolds will connect to the air supply, and each worker will access a separate line for entry. Simply adding additional manifolds to the supply is not an acceptable method to increase the number of workers. Each line added to the system will increase the volume demand and decrease the pressure for all workers within the system. Remember that each mask needs a minimum pressure and air volume to function correctly. Always follow the manufacturer's guidance and limits for the number of workers and distribution manifolds. There are several types of airlines used in confined space entry operations. These can be classified as high-pressure mainlines, used to deliver air from the trailer to the manifold, or breathing airlines to deliver low pressure to workers. These airlines are designed to work with a system of confined space entry and are not industrial-grade air hose. Specialty connectors are used to ensure hoses do not come uncoupled during work activity. Airlines may be physically compatible, but are not designed to work together in a system. Ensure that all of the components are designed to work together as per the manufacturer guidelines. Another consideration is that the approved air supply hose shall not exceed a maximum of 90 meters, 300 feet in length, and some hoses are only approved for shorter lengths. Refer to the manufacturer guidelines and instructions. Dew point. Dew point is the temperature air is cooled for water vapor to condense out. In supplied air systems, if the temperature falls below the dew point, water can pool, creating a blockage and potentially freeze, cutting off the air supply to the worker. This condition may be undetectable at the air source, as the pressure will read normal. In addition to dew point limits, there are a number of quality checks and limits for breathing air supplies. CSA Standard Z 180.1 Compressed Air Breathing Systems outlines these requirements. Equipment is critical to being able to work safely in a confined space environment. Understand the limits of the equipment and what equipment is best suited for that environment.